In this lesson we're going to look at groups 7 and 8 of the periodic table. So group 7 is this group, okay, and that is known as the halogens, and group 8 is this group, which is known as the noble gases or the inert gases. So we're going to have a look at group 8 first of all. In the next lesson you'll be looking at the atomic structure of the elements, and all I'm going to say now is that in the case of these elements, the noble gases, they all have what is called a stable electronic structure. None of the other elements have this, only the group 8, and for that reason they have no real desire, to react with any other element, okay, not even with themselves. So as a result of this stable electronic structure, we can say the noble gases are unreactive and they exist as monoatomic gases. Remember that all of the other gases in the periodic table, that's to say chlorine, fluorine, oxygen, nitrogen and hydrogen, they all join up in pairs to form molecules. Now, because these are completely unreactive, they don't even want to do that, they just want to live on their own. And so there's not much we can say about them really, except for example looking at their physical properties. And one thing that the noble gases are famous for is, of course, when you pass an electric current through them, and they have a tendency to light up and shine with particularly defined colours. For example, neon characteristically emits this red light, with argon emits this bluishy purple ultraviolet light. Okay, so we can say that noble gases glow when an electric current passes through them. So what about group 7, the halogens? So first of all, these can be gases, for example in the case of fluorine, and they're colour gases. Both fluorine and chlorine have this greenish yellowish kind of hue, so they can be gases. They can be liquids, as in the case of bromine, and they can be solids, as in the case of iodine. Now these three here, iodine, bromine and chlorine, you're likely to encounter in the laboratory. Now what we can say about these substances are they are highly toxic and quite reactive. Unlike with the group 1 elements, where the reactivity increases as you go down the group, with the group 7 elements, with the halogens, the reactivity increases as you move up the group. Okay, so let's for example take a look at the reaction of the halogens with hydrogen, taking chlorine as our first example. So how do group 7 elements react with hydrogen? Well, we can see that chlorine plus hydrogen, both of these are gases, react to form a new gas called hydrogen chloride. Okay, so we can write that as Cl2, chlorine, H2. Both of these are, as we said, diatomic gases, and they form hydrogen chloride, which if dissolved in water will produce hydrochloric acid. Well, you can see that equation is not balanced. We have 2 chlorines here and only 1 here, and 2 hydrogens and only 1 on the other side, so we can easily balance that by putting a 2 there in front of the HCl. Okay, now we've got a balanced equation, and this is the same format for each of the reactions with each of these halogens, but what will be different is the intensity of the reaction. When fluorine reacts with hydrogen, then it will do so on contact. So just However, when chlorine reacts with hydrogen, well, that won't happen on contact, but you can make the two react just by illuminating the mixture with a UV light. Now in the case of bromine, well, bromine requires a flame in order to ignite the mixture, and iodine, well, iodine only partially combines with hydrogen, even with constant heating. So you can see the pattern here is that the reactivity of the halogens decreases as you move down the group.